Good morning. This is Veeraswamy, working as an assistant professor in the Department of Electronics and Communication Engineering, and then staff Aeronautical in the Department of Electronics and Communications in Hyderabad, Dundigal. Today, we are going to discuss the topic is the basic cellular mobile system from the mobile communication system. From the mobile communication system, the today's topic is a basic cellular mobile system. So, in these topics, the basic cellular system, which type of technology is used to implementation of the communication. So here in wireless communication, different types of. So before going that, I prepared these slides by taking the reference of this textbook, that is Mobile Cellular Telecommunication, and the author is C.Y. Lee, and the publication is Tata McGraw-Hill Publications Company Limited. So in this topic, the basic is the cellular networks basics. So the cellular network is based on the radio signals. So the radio based signal, the cellular network telephone is radio based system. So the radio waves are electromagnetic waves that antenna propagates. So I am repeating here, the cellular network basics is here. The cellular network or telephone network, it is radio based technology. So radio based technology is nothing but radio wave, electromagnetic radio waves we are using for the establishment of the communication and for the transmission of the signal or the transmission of the data from the transmitter, the receiver, or a mobile unit to the base unit or base station to the mobile station. So here mostly in cellular communication system, the basically we are using the frequency bands that are 850 megahertz, 900 megahertz, 1800 megahertz, 1900 megahertz frequency bands are we are using for the mobile communication or the cellular communication data transmission. So see here in this slide here, the most signals are 850 megahertz, 900 megahertz, 1800 megahertz and 1900 megahertz frequency band signals only we are using for the transmission of the data from the base station to our antenna to the mobile unit or base station to mobile unit. So these are the basic frequency bands we are using. So here in cellular network, the different wave evolutions are there. So it is useful to think the cellular network generations here. Basically, now we are using 5G, the advanced next one is the 6G communication. So, how the evolution done in mobile communication? So, it is useful to think the cellular telephony in terms of generation. So, here the G is nothing but here generation. So, basically, the 0G is nothing but a briefcase size mobile radio telephones we are used for the establishment and we are transferring for the purpose of the transferring the data from the source to the destination or one place to the another place. So here 1G communication, the next one is from the 0Z, that is basic one. The next one is 1G, that is first generation mobile communication, that is analog cellular telephony is used here. The 2G is nothing but second generation, and the third generation is high speed digital cellular telephony, video telephony establishment. And the next one is a 4G LTE, that is long term evolution, that is IP based, internet protocol based version, that is anytime anywhere we can exchange the data that in terms of voice or data multimedia telephone, the faster data rates than the 3G signals. So the last one, now we are using the 5G technology, that is a fifth generation of wireless communication technology or mobile communication technology. So these are the basic generations. So the evolutions of mobile communications are 0G, 1G, 2G, 3G and 4G. Now it is 5G. Fifth generation. The next feature that is going to implement in our country, that is the 6G, that is sixth generation mobile communication. So here the evolutions of networks. See here in this slide here, the first generation. The first generation here it is in the form of the FDMA, that is frequency division multiple access. In the last session we have discussed that different types of multiplexing technology, that is TDMA, FDMA and CDMA, that is frequency division multiplexing, time division multiplexing and code division multiplexing, that is orthogonal frequency division multiplexing also now introduced in the 4G communication. So in the first generation they are used the analog communication, that is frequency division multiplexing, that is frequency division multiple access. So before going to discuss the evolutions of that is FDMA, TDMA, what is multiple access here? So the multiple access is nothing but here one channel can carry. So say here, see, I have given an example here 1, 2, 3, 4, 5. 1, 2, 3, 4. So 5 users are there, and here it is a receiver side. This is the destination, this is the transmitter, and this is the receiver. So what is happening here? The multiple access is nothing but the multiple inputs are placed on one channel, that channel carries the information to the receiver side. I'm repeating here, the multiple access is nothing but the multiple users, that is nothing but multiple transmitters are placing the data on the single channel. That single channel carries the information to the destination side. So that is called as the multiple access. It can take the channel which carries the information, it takes the information from the multiple users, and that multiple users data placed on the channel, that channel can carry the information to the destination side or receiver side. So that is multiple access. So before multiple access, before sending the or before placing the data of each user, if the channel is busy, then for example, user 1 is there, user 3 is there. At the same time, the user 1 and user 3 want to place the data on this channel, then what is happened? The data will be overlapped. Then what we are doing here, the multiple multiplexing techniques are we are applying here. That is frequency division, time division, code division, and orthogonal frequency division multiple. So these are the different multiple access techniques. So in this, the first generation mobile communication or wireless communication is established on the analog communication technology, that is frequency division multiple access. So then after the second generation, that is the TDMA, that in when the TDMA is introduced, that is time division multiple access introduced, then that is the GSM technology, that is the global service for mobile communication, that is introduced there. The next one is 2.5, that is edge technology, again based on the third one, that is TDMA only. The next one is a third generation, that is the third generation here, nothing but code division multiple access techniques, that is multiple access technique is introduced here. So again in the CDMA, there are the CDMA is code division multiple access. So the CDMA is again categorized. CDMA is categorized as CDMA CA and CDMA CA, CDMA CD. So the CDMA CA is nothing but code division multiple access collision avoidance, and the CDMA CD is nothing but code division multiple access collision detection. So when the code division multiple access technique is introduced in the third generation mobile communication system, so the code division is nothing but here the complete data, the data is divided into codes, and each code is transmitting as slots wise. So when the data is transmitting according that, the CA is nothing but collision avoidance, the CD. So when the collision is detected, we have to avoid the collision, right? So the detection, the collision detection, when it has occurred, then the detection, that collision, we have to avoid that. So the technique is I here introduced, that is collision avoidance, that is CDMA CA. So the last one is LTE, that is long term evolution, the OFDM, that is a frequency division multiple, that is orthogonal frequency division multiplexing technique is introduced in the fourth generation. So coming to here, the cellular network, already we discussed that the 1G, 2G, and here see, the IS is nothing but internet service, that is 136 here in the edge technology is connected here, and the 1X is DO0, that is given as the CDMA as well as for the LTE long term evolution system. So here we will discuss in brief when the 1G is introduced, 2G is introduced, 3G introduced, when the 4G is introduced, and what are the frequency band, we will discuss in the next time in the further slides. So the basic network here, the basic cellular network here is the base station transmit and receives from the mobiles and assigned spectrum. So the base stations can transmit and receives from the mobiles and the assigned spectrum here. By using assigned spectrum only, the base station can transmit as well as it can receive from the mobile unit. So the multiple base station use the same spectrum, that is nothing but here the spectrum reuse. Already we discussed that frequency reuse, right? So the frequency reuse nothing but the same frequency is assigned for the multiple cells. The each cell is assigned for the same frequency band. But here the multiple base stations are using same spectrum. The same, when these are all using same spectrum band, so that type is called the spectrum reuse. So the service area of each base station is called a cell. Already we discussed that what is a cell. Then after how the cells are assigned and cell strategy, how the cells, already we discussed that. So the cell is nothing but here each cell is acts as a base station. So each cell is acts as a base station. So if the base station is nothing but it can transmit the data as well as receives the data from the mobile by using particular frequency band or spectrum band, right? So each mobile terminal is typically served by the closest base station. So and then see here this image. This is the mobile unit here, and this is the mobile unit, and here this is one base station, and this is another one base station, is another base station. So each mobile unit is connected to its nearest base station only. Then this mobile unit is connected to this base station, and this mobile unit can connect to this base station as well as from this base station also. So here, when the PSTN is there, when the PSTN, the public switch telephone network is there, then automatically the surrounding mobiles are connected to that base station only. So here the point is here, each mobile terminal is typically served by the closest base station. Then handoff, when the handoff is nothing but here, I will explain here. So already we discussed that handoff, but I will again explain here. So this is the base station and the coverage area of the radius of this base station. This is the coverage area. And this is the base station and the coverage area of this base station is this area. And the same time, this is the base station and the coverage area is this one. So here, 3 base stations are there. For these 3 base stations, 3 coverage areas are available. At the same time, here only 2 mobiles, the mobile unit 1 and mobile unit 2. 2 mobile units are available, 3 base stations are available. So what is happening here, when the mobile unit is connected to the base station and the communication is established between the transmitter to the receiver and the mobile conversation is started. So this mobile unit, the person who is utilizing, who is using this mobile, he is entering and to the another base station area. So when he is entering into the another base station area, then the call is not disconnecting. Automatically what is happens, the frequency of this band is connected to this mobile unit automatically. So there is no call drop. So here I am explaining again, the handoff technique is nothing but here, without disturbing or without disconnecting or without dropping any call, it is entering the continuous mobile communication or the conversation continuous from the one base location area to the another base location. I am repeating, from another one base location to or one base station location to the another base station location, the mobile unit is moving without dropping the call. That technique is called as the handoff technique. So here, the multiple access problem here. So multiple access is nothing but each base station is serving to the multiple users. So what is happening? The base station need to serve many mobile terminals at the same time, right? So the uplink and downlink. So for example here, the downlink and uplink is nothing but the base station have to serve the different or n number of users are connected to that base station. So when the n number of users are connected to the base station, that base station have to serve these, its frequency utilization will be done to the all the n number of mobile units. So what is happening? All the mobiles in the need to be transmitted from the base station. All mobiles in the cell need to transmit to the base station. So interference among the different senders and receivers will be happens. So when the interference will occur, when different mobile units are connected to the same frequency band, then or each cell is utilizing with the same frequency band, then only the interference will be occur. So this is the main problem here. To overcome this interference, we are introducing the multiple access problem. So here the multiple access is nothing but, so we need here multiple access scheme to avoid the interference between the users and to avoid the interference between the cells here. So just now we discussed that what is multiple access here, right? So the multiple access introduced for the overcoming of the interference among the different senders and receivers only. Then see here the multiple access schemes. So basically here three orthogonal schemes are available. So then the first one is FDMA, the second one is TDMA, and the third one is code division, that is CDMA. So the multiple access schemes are 3 types. Basically 3 orthogonal schemes are available. That is the frequency division multiplexing, time division multiplexing, and code division multiplexing. Then see here, I am taking here, that is y-axis, here x-axis, and this is z-axis. I am taking time on x-axis, frequency bands on y-axis, and I am taking code on the z-axis. We will discuss in the next. What is FDMA, what is CDMA, how works the CDMA works, how TDMA works, and how FDMA works. So basically here, 3 orthogonal frequencies or orthogonal schemes are available. That is nothing but here multiple access schemes. Then see the first one, that is FDMA. So the FDMA is nothing but here, each mobile is assigned a separate frequency channel for a call. Then I am repeating, each mobile is assigned to a separate frequency channel to establish for a single call. Then see here, the frequency guard bands are introduced here. These are the guard bands. So separate frequency for each mobile unit, or each mobile is assigned to a separate frequency channel for a call, for the establishment of the call. So guard band is required to prevent the adjacent channel interference. Then see here, these are the guard bands. These are the guard bands. The use of the guard bands here is the guard bands required to prevent the adjacent channel interference. Then usually one downlink and one so here the guard bands are introduced, right? So usually one is downlink and one is uplink is connected for the mobile unit. So different cellular network protocols are used in different frequencies here. So here the different cellular networks, for example, Airtel is there, Jio, BSNL. So these are the different network providers. So different cellular network protocols using different frequencies. So the frequency is precious and scarce because of we are running out of it. That is called as the cognitive radio network. We are entering into the from the electromagnetic signal radios to the cognitive radio networks. The next one is time division multiplexing. So what is time division multiplexing? But time is dividing into slots and only one mobile terminal is transmit during each slot. So see here. So this is the complete time. For this, this is the slot one. I am dividing this complete time into. The time is dividing into slots wise. So for each slot is connected to each mobile terminal. The time is dividing into slots and only one mobile terminal transmit during each slot. For example, here 1, 2, 3, 4 mobile units are there. In this slot, the mobile 1 only can transmit the signal. In this slot 2, the mobile 2 is only can transmit the signal. In the slot 3, the mobile 3 is only transmitting each slot. So here what is happening? The complete time is dividing into slots wise. So each slot is allocated to each mobile unit. So then for that slot, in that slot, that mobile only can transmit the signal. That mobile can only receive the signal. That is the time division. So like during the lecture, only one can talk. So now I am delivering the lecture. I am delivering the lecture. So only one can talk, but others all will be listening that my words, right? The same as here, when the unit 1 is transmitting the signal, the remaining these mobile units are on calm mode. That is nothing but here these three are not connected to that slot. The mobile which is connected to the slot, that's in that slot only the mobile can be transmit the signal. So each user is given a specific slot here. Just now I discussed that. I explained that each user is given to specific slot only. So no competition is there. There is no competition, right? Because of each slot is allocated to each user. For a single slot is allocated to single user only, right? So that's why there is no competition in the network. So unlike the carriers that is CSMA, carrier sense multiple access. So the CSMA is nothing but here I will explain. Right, I will explain here only. So the CSMA, carrier sense multiple access. The CSMA, carrier sense multiple access is nothing but multiple access already we discussed. Carrier sense. What is carrier sense? So here this is the transmitter and this is the receiver. So what is happening? This is the carrier, right? The carrier here is nothing but channel. So what is sensing here? For example, here 4 slots are there for transmitter side. For 4 slots are allocated to 4 users. So when user 1 is want to connect with this slot, then the user one has to check the status of this channel. If the channel is ideal, then only the user 1 can place the data on the channel or that carrier. That is, he is sensing the status of this channel. If the channel is ideal, then only the user can place data on that channel. That channel can carry the information to the receiver side. That is nothing but here carrier sense before transmit. The carrier sense multiple access is nothing but here sense before transmit. What we have to sense? If the channel is busy, then we have to stop transmitting information. If the channel is idle or the channel is free, then we can place or we can transmit the signal and we can place the data on the channel. The channel can carry the information to the receiver side or destination. That is carrier sense multiple access. Next one is the code division multiple access. Then see here, The code division multiplex but use of orthogonal code separate a different transmission we are introducing here. Each symbol of bit is transmitted as a larger number of bits using the specific code spreading. Here is nothing but the bandwidth, the complete bandwidth we are dividing here. So see here, for example, this is one data code and this is one another data, this is another data. So the complete data can be, again we are into orthogonal data. We are doing transmitting data by using orthogonality only. So the bandwidth occupied by the signal much larger than information transmission rate. So the bandwidth will be occupied by the signal is much larger than the information transmitter rate. But all the users are using same frequency band here. So in the code division multiplex is the orthogonal codes to separate the different transmission only. But in different transmission, they are connected to the signal, they are connected to the base station. All the users are using same frequency band here only. So the orthogonal among users, the data signal is here. That in that for the data signal, the pseudo random code is added to the original signal. The pseudo random code is added to the original signal. The pseudo random code can be transmitted signal, data signal, that is by using XOR gate only. That is XOR with the pseudo random gate. That is the code division multiple access. So the next we are discuss now different types of multiple techniques, multiple access techniques, right? So now this is the evolution of the mobile communication network. So the first one is 1G communication, next one 2G, 3G, 4G, 5G, and here it is 6G. Now we are at the 5G only. 6G they are developing now. It will be expected in the 2030. We will expect the 6G communication. So one by one we will discover now what is 1G, what is 2G. We will discover what is the frequency they are used, what is the speed in that 1G, what is the speed in 2G. So in each generation we will discuss. So here 1G, 2G, 3G is there, right? So what is G here first of all? So here the G is nothing but generation. So basically the different generations are available in mobile communication. That is 0G, 1G, 2G, 3G, 4G, 5G, it is 6G in the future. So the G is nothing but generation. For which generation? For what? The generation of wireless telephone technology or wireless mobile communication or mobile communication technologies here. So now we are going to discuss one by one. So then see, the first 1G is called as here the birth of mobile communication here. So birth of, at the time of birth of mobile communication, it is developed in the year of 1980 and completed in the 1990. So 1980 to 1990, nearly 10 years. And the frequency used in the 1G communication, that is 150 megahertz, that is to 900 megahertz here. And the bandwidth here is analog communication bandwidth, that is 30 kilohertz of frequency they are used here. And this is also called as the analog system based communication. And the speed in the 1G communication, that is 2.4 kilohertz. That is kbps. The speed is, the units for the speed is kbps here, right? That is mbps, kbps, gbps, or bits per second. So when they are developed the 1G, or when they are invented, or when they are came into the function, that is, this is used for the advanced mobile telephone system only. It was launched in by US country. It was in mobile 1G communication system, that is 1G telephone systems. And this is allows only users to make the calls within the country, in single country only. And it is taken 10 years for the 1980 to 1990, developed in 1980 and completed in the 1990. This is the 1G communication. Next, the 2G communication here is, right. So here this is the image 1G communication at the time of 1G communication. This type of mobiles are used. This type of devices are used for the communication purpose. The next one is 2G. That is second generation. It is called as the advent of digital communication. So the 1G is invented for the analog communication. When the 1G is introduced, then the analog communication is introduced for that. But when the 2G is there, then the digital communication introduced here, and it is developed in the year of 1980 to 1990 only. When they are started 1G, then only they are started they are started working on the 2G communication also. And the frequency here they are using at 1.8 gigahertz, and it is the digital communication purpose. 1G is for the analog communication. The 2G is for the digital communication, and the frequency here they are utilizing here 1.8 gigahertz frequency, and the bandwidth is up to 900 megahertz of frequency, and the speed is up to 64. But here in the 1G communication, that is 144 kbps only. Sorry, this is right. So here 2.4 kbps. It is went 2.4 kbps to 2.4 kbps to 64 kbps. And here, when they are introduced the 2G communication, they are used for the short message communications and voice calls only. Service as the digital voice and SMS with more clarity, semi-global facility. So we can call to another country also. So the 2G are the handset we are using today, that with the 2.5 capabilities, and it take the time from the 1991 to 2000. The serving of the 1G 2G communication is served in the 1991 to 2000. The next one is 3G communication. So the era of mobile internet. So when the 3G communication introduced, then only the starting of the data, that is the browsing of the data, that is nothing but here internet protocol is introduced here, and the internet starting browsing and the 3G communication only. So it is developed in the year of 1990 to 2000. So when from the 1990 to 2000 they are invented, that is the developed in the year of completely 2000, and it started utilization in the 2000. And the frequency is 1.6 gigahertz to 2 gigahertz, and the bandwidth is 100 megahertz of frequency utilized for the bandwidth the transmission of the data, and the speed is up to here. So here 1G communication, that is 2.4 kbps, that is to the 2G communication, that is 1G, 2G, here 3G is 64 to 144 to 2 mbps. So here the data speed is increased here, transmission speed is increased in the 3G communication. So this is the better voice quality is improved here, and good clarity in video conferences also. So when the 3G introduced, the email, PDA, information suffering, and online shopping, banking, games, etc. are utilized for the 3G is invented. Then after the full functioning is done in the email working, the full function information, online shopping and banking and games. This is the global roaming. You can roam in the global roaming only. And from 2000 year to the 2010, up to 10 years, it served the 3G communication. So after that, the 4G communication, the rise of mobile broadband here. The mobile broadbands are introduced in the year of 2010 only, and developed the 4G communication also developed in the 2010 only. So the frequency utilized here 2 to 8 gigahertz of frequency utilized for the frequency utilization, as well as the band is here. The C here for the 3G communication also here 100 megahertz of bandwidth only. At the same time for the 4G also 100 megahertz of bandwidth. But here what is different here, real-time video streaming is came utilization that functioning in the 4G communication only. So the 4G significantly increased the data speeds and reduced latency, making real-time video streaming, online gaming and high-quality video calls and reality here. The speed is up to 100 Mbps to 1 Gbps of speed introduced in the 4G communication. And when the speed is increased, then automatically the performance will be increased. And the easy roaming here, if we are in India, if you are going to USA, we can utilize the same network, that is 4G communication handset we can use in that US only, and very low cost. And the serving of the 4G communication is from 2010 to 2020. Up to 2020 we are used 4G communication. After 4G, that is after 2020, that 5G is introduced here. That is the 5G communication. That is 5G is nothing but more than just fastest internet, that is faster internet. So in the 5G, the next step in the evolution of mobile communication, the 5G is the next step of the evolution of mobile network communication. It was designed to provide greater rates of data transmission, low latency and improve reliability compared to previous generations. So when the reliability is increased, then automatically the data speed is also increased. The data transmission is also increased, then automatically the performance is improved here. So enabling new use case and transforming a wide range of industries. This is the 5G. Then see here, the 5G network can support a much larger number of devices that can prevent generations and can also handle more data intensive applications such as virtual and augmented reality, autonomous vehicles, and the IoT Internet of Things are introduced here. So the 5G communication can support for these all the virtual and augmented reality, autonomous vehicles are introduced, and IoT is connected to the internet, that is Internet of Things. The the electronic vehicle is connected to the internet nowadays. We can operate that in IoT when we are connecting our home, that is the home appliances, that is air conditioner, the water machine, washing machines are there. We can connect our, when we are sitting in the office, we can operate in our home appliances in our, we can operate from our office only. So we can turn on the AC, we can turn off, we can turn on the fans, we can turn off the fans, we can turn on. So the different, when the 5G is introduced, the IoT is improved here. So with 5G, we have seen new invention, that is opportunities in variety market verticals such as healthcare also we can monitor by IoT using. Manufacturing, transportations and entertainment. 5G also is a key driver for technology such as edge computing, artificial intelligence, ECAI. That is, this is the key drive technology such as for edge computing and artificial intelligence. So the 5G is continuing to grow the development of MPS, that is mobile service providers throughout the world and rolling out their 5G networks, and it will be exciting to see the new use cases that enable as moving towards 2020. From 2020 onwards, we all are using 5G networks and 5G, and this 5G is connected to our home appliances also. As well as when the 5G is increased, then IoT devices are improved and IoT devices are came in the functioning. At the same time, AI/ML, artificial intelligence and machine learning is connected to your 5G networks also. Next. So these are the comparison table, the comparison of 1G to 5G technologies. So these are the technologies. So which type of technology used in there? And these are the generations: 1G, 1G, 2G, 2.5G, 3G, 4G, and 5G. Then see here, deployment. So just now we discussed that from the 1917 to 1984 here, and the 2G is here 1980 to 1999. 1999 to 2000, 2000 to 2010, 2014 to 2015, that is 5G. So these are the deployment. So the bandwidth utilized or the bandwidth used for the establishment of the generations here. So in the 1G, that is 2 kbps only. The 2 kbps improved for the 2G, that is 64 kbps speed. Here the bandwidth is nothing but transmission speed. At the same time, for the 3G, that is 2 Mbps. From the 2 Mbps, it is 200 Mbps. From 200 Mbps to above 1 Gbps. And the technology, just now we discussed the different technology, that is CDMA, FDMA, right? So here, that is the multiplexing techniques used, that multiple access techniques are used for the transmission of the data from the source to destination. That is, in the 1G communication, FDMA we discussed already. The TDMA here, CDMA here also CDMA, OFDMA, CDMA in the 5G communication. At the same time here, the switching is already we discussed in the last session, that is, which type of switching is established here to transmit of the data, circuit switching or packet switching or any other air interface packets. So here, types of switching technology is also introduced here. The next one is handoff here, the horizontal handoff here. So all are here 1G, 2G, 3G and 4G. But here 4G horizontal as well as vertical, and here 5G also horizontal and as well as vertical handoff technologies are introduced. Thank you. These are the today's topic. We will come from the new topic in the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.